Kīlauea Volcano Update, Episode 30, Forecast for July 31st. Science Alert. Brace yourself, Kīlauea might be ready to put on its next big show, and the timing could catch everyone off guard. The story unfolding at the summit of Hawaii's legendary Kīlauea Volcano is far from over. Scientists are closely tracking a tense pause in eruptive activity, but all signs suggest a fresh surge of lava, and a new chapter in this dramatic volcanic saga may be just days away. Here's what's unfolding. Experts from the USGS Hawaiian Volcano Observatory have been watching the volcano's every move. According to their latest analysis on Thursday, inflation to Kilauea's summit, a telltale sign the magma chamber is refilling, points to the possibility that the long-awaited episode 30 of this eruption sequence could ignite around July 31st, or perhaps even later. So what does this mean? The USGS keeps Kīlauea's volcano alert level at watch. That means scientists believe an eruption is possible and are keeping a sharp eye out for any warning signs. Meanwhile, both the east rift zone and the southwest rift zone remain quiet, with no significant unrest detected in these historically active areas, at least for now. But here's where it gets controversial. Some experts argue that quiet rift zones offer a false sense of security, since Kīlauea's behavior can shift unexpectedly. Let's rewind a bit. Earlier this month, episode 29 wrapped up on July 20th, 2025. The moment the episode ended, inflation at the summit started again right away, confirming what scientists expect as pressure rebuilds beneath the surface. Low-level tremors and the continuous release of volcanic gases, called degassing, have been ticking along steadily. These are subtle but important signals that the volcano remains active, just beneath the threshold of a fresh eruption. Now, what makes this eruption unique? Episode after episode, Kilauea's current sequence has been marked by periodic, almost rhythmic bursts of lava fountains, a style not widely observed since the dramatic fountaining events at the beginning of the Pu'u'o eruption in the early 1980s. In the latest activity, lava has erupted from two key sites inside the Halemaʻumaʻu crater. Scientists have conveniently labeled them the North Vent and the South Vent. Each eruptive episode can last dramatically different lengths of time, from just a few hours to a week or more, and each has been paired with intense deflation of the summit. Imagine the surface sinking as magma is forced out. Here's the twist that most people miss. Whenever these fountain episodes pause, the volcano instantly flexes from deflation to inflation as magma returns and pressure builds for the next potential burst. And this pattern isn't random. Since eruptive activity dramatically restarted on December 23rd, 2024, these explosive fountains have been occurring roughly once a week, making Kīlauea a volcano with a predictable yet breathtakingly powerful rhythm, although history has taught us that volcanoes can defy even the best scientific predictions. But let's open up the debate. Some in the scientific community believe this cycle of weekly lava surges is just the beginning, and warn that the longer pauses, or its shift to the rift zones, could signal deeper changes in Kīlauea's behavior. Do you think we're really seeing a new normal to the volcano? Or are there bigger surprises looming? Should local residents place trust in the current patterns, or prepare for potential curveballs? We want to hear from you. Does this steady parade of fountaining episodes put your mind at ease, or raise new concerns? Share your thoughts and join the conversation below. Kīlauea Eruption. Lava fountains and crater transformations. Imagine waking up to the sight of molten lava fountains shooting into the sky. That's exactly what happened on the morning of July 20th, 2025, at Hawaii's Kīlauea Volcano. This spectacular display marked the 29th eruptive episode in a series of periodic activities within Halemaʻumaʻu crater, which began on December 23rd, 2024. The Operational Land Imager, OLI, on Landsat 8 captured a stunning image at around 10:44 a.m. local time, showcasing the natural color view overlaid with an infrared signature. This combination revealed the intense heat radiating from the lava within the summit crater, along with visible clouds and a volcanic plume. The U.S. Geological Survey Hawaiian Volcano Observatory, HVO, reported that these lava fountains persisted for over 13 hours, reaching heights of less than 330 feet, 100 meters, While this might seem modest compared to previous episodes where lava shot over 1,000 feet, 300 meters into the air, this particular event produced more voluminous lava flows. In fact, it covered approximately 80% of the crater floor with fresh lava. But here's where it gets controversial. Despite the fountains dying down by the evening, some degassing and seismic tremors continued, hinting at the possibility of another episode. The summit area also began to reinflate, a process measured by tilt meters on the volcano. These instruments detect cycles of inflation and deflation, which correspond to the buildup and release of magma beneath the surface. As of July 23rd, experts were eagerly awaiting more data to predict when the next episode might occur. Historically, breaks between recent episodes have ranged from 6 to 10 days. This episodic behavior was last observed at Kīlauea from 1983 to 1986, during the start of the Pu'u eruption. And this is the part most people miss. The unpredictable nature of volcanic activity means that even with advanced technology, forecasting the next eruption remains a challenge. So, what do you think? Could we ever accurately predict volcanic eruptions? Or is the unpredictability part of nature's charm? Share your thoughts in the comments below. Kīlauea Summit Eruption. Episode 29, Lava Fountains and Measurements. A volcanic spectacle unleashed. Kilauea's fiery episode 29 captured in stunning detail. On July 20th, 2025, the raw power of Kilauea's summit eruption reached a dramatic peak during episode 29, and what scientists discovered might reshape how we understand volcanic hazards. At 5:15 a.m. HST, lava began erupting from Halemaʻumaʻu crater, with the north vent producing fountains so intense they dwarfed recent events. By 7:10 a.m., USGS Hawaiian Volcano Observatory scientists had already deployed cutting-edge tools to document the chaos. A laser rangefinder captured this pivotal moment, revealing a north vent significantly wider than in prior episodes. For perspective, the scorched mound directly in front of it stood 89 feet, 27 meters tall, nearly the height of a 9-story building. But here's where it gets controversial. While the north vent dominated, the south vent, visible to the left, sputtered intermittently, active for just 6 of the eruption's 13 hours. Why such inconsistency? This erratic behavior has sparked debates about magma chamber dynamics. USGS teams risked their safety with Hawaii Volcanoes National Park's authorization to gather critical data. From the caldera rim, the scientists measured lava channels racing at 16 to 20 feet per second, 5 to 6 meters per second, using laser technology. These things aren't just numbers, they're clues to predicting flow paths and evacuation needs. Meanwhile, another team braved toxic gases to analyze emissions with an FTIR spectrometer, a device that identifies gas composition through infrared light. The results? A 100-foot, 30-meter lava fountain and gases hinting at magma stored deep below. And this is the part most people miss. These measurements aren't just academic. They directly inform hazard warnings for nearby communities. Controversy alert. Should scientists be allowed to work so close to active eruptions? Critics argue the risks are extreme, while advocates insist the data saves lives. The lava itself didn't hold back. Flows from the north vent surged 1.5 miles, or 2.5 kilometers across the caldera floor, a stark reminder of Kilauea's reach. Yet amid the danger, one question lingers. How do we balance scientific curiosity with human safety? What's your take? Share your thoughts below. Do the breakthroughs justify the peril, or should we rethink how we monitor volcanoes?